Welcome. Today we are going to solve another 3 problem under the topic frequency domain analysis. So coming to the first problem, that is 44th question. A system with a transfer function g of s equal to 1 by s plus 1 into s plus a, where a is greater than 0, is subjected to an input 5 cos 3t. The steady state output of the system is 1 by root 10 cos 3t minus 1.892. The value of a is, so we have to find the value of a in the transfer function. So for that, we know that the given input, the given input is 5 cos 3t, and from that we can find the frequency of the input is 3 radian per second. And given that the transfer function g of s is 1 by s plus 1 into s plus a, just substitute, instead of s, just substitute j omega. So you would get that in complex number format, and taking the magnitude, you would get 1 by root of 1 plus omega square into root of a square plus omega square, which gives the magnitude of the transfer function. So you know that the output should be in the will be the same frequency as that of the input. So just substitute omega is equal to 3 in the given transfer function, so that you will get this value, and the output will be of the form, the amplitude is given, and also the phase angle of the output is given. So the amplitude of the output will be of the form that is given by the product of the amplitude of the input as well as the amplitude of the given system. So just find the product, 5 into 1 by root 10 into root of a square plus 9. So that by solving this, you will get a is equal to 4. Hence the problem. Coming to the 45th problem. So for the unity feedback control system with the forward path transfer function g of s equal to k by s into s plus 2. The peak resonant magnitude m of the closed loop frequency response is 2. The corresponding value of the gain k correct to 2 decimal places is. So you have to find the value of k, which is greater than 0. And given that the closed loop transfer function, so they have given the g of s equal to k by s into s plus 2. So from this, just construct the closed loop transfer function, so which is k by s square plus 2s plus 1. So keep that as one first equation. And coming to the resonant peak, it is given that the resonant peak, the peak resonant magnitude m of the closed loop frequency response is 2. So the resonant peak mr is 2, whose formula is given by 1 by 2 psi into root of 1 minus I square. On solving this, you will get two values for psi, 0.966 as well as 0.259. You know that psi cannot be greater than 0.707 because the resonant peak doesn't exist for psi greater than 0.707. So we choose psi to be 0.259. And we know that from the equation 1, that is k by s square plus 2s plus k, this is of the standard second order form. Yes. So just comparing with the standard second order system, you can find the omega n square, which is given by k, as well as the second term 2 psi omega n is given by 2. Just solve this one, you will get the value of k as 14.91. Hence the problem. Coming to the 46th question, the transfer function of a second order closed loop system is given as c of s by r of s, which is 32 by s square plus 2s plus 60. So the resonant frequency and resonant peak is, they have asked to find the resonant frequency and resonant peak. We know that the formula for the resonant peak is omega r equal to omega n root of 1 minus 2 psi square, as well as they have asked to find the resonant peak, right? So resonant peak formula is given by mr equal to 1 by 2 psi into root of 1 minus psi square. So for both of this problem, we need the values for psi as well as the omega n, which is natural frequency. They have given the closed loop transfer function, which is 32 by s square plus 2s plus 60. So which is of the form k into omega n square divided by s square plus 2 psi omega n s plus omega n square, where k is the some gain greater than 0. So on comparing this with the standard second order equation, you can get the value of k as 2 and omega n to be 16. Omega n square to be 16, from which you will get the natural frequency to be 4 radian per second, and comparing the second term with the second term, you will be getting the psi as 0.25, which is damping ratio. On substituting in the respective formulas of resonant frequency as well as the resonant peak, you would get the answer as omega r equal to 3.74 radian per second. And coming to the resonant peak, they have asked in the dB format. So just find 20 log of that answer, which would fetch you 6.30 dB. Hence the problems. Thank you.